Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful for the entrance exams or competitive exams in the international floor. In the national level, JE Advanced and JE Mains examination for IETs and NITs, and a NEET exam for medical entrance examination. In addition to this one, Telangana and Andhra Pradesh MSET exam for engineering stream, and if you are aspiring for any competitive exam conducted by various government organizations, there you can find the general science question paper as the common one in general science paper will be found. So that kind of thing can be available in this session. So let's enter into our today's session. Draw the following compounds as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per IUPAC, the compounds are given. So earlier, the entire session we are going through, we are discussing about compound is given and we are assigning the name as per the IUPAC protocols. Here some word change we found. Name is given as per the IUPAC protocols. We have to assign its a chemical composition, chemical structure to be drawn, right? Draw the structure for each compound 2,3 dimethyl butane, and second is 2-propyl 2-methyl methylene pentane. Sorry, heptane to be taken. Okay, so second compound is heptane, first compound is butane. Let's see how can we draw this. In order to draw this 2,3 dimethyl butane, first of all, we have to go with the skeletal structure. This is called a parent chain, where you can find a bute. Bute stands for 4 carbon length chain. So that first of all, we have to draw 4 carbons in a straight line. Later on, they mentioned methyl on the second and third position. Just to put the second, third methyl over here. So after this one, we have to balance their valency. As everybody aware, carbon is tetravalent in nature. We have to assign 4 bonds around the carbon atom. So already one bond is there for the first carbon. So that put 3 hydrogens over there. Second carbon is having 3 bonds, so that one more hydrogen is required. And third carbon is also having 3 bonds, so that one more hydrogen to be introduced. And this terminal carbon is of 1 bond, so that more 3 bonds required with 3 hydrogens. This is the way we can assign chemical structure for the given organic compound as per the IUPAC protocols. First, parent skeleton to be drawn, and whatever substance are there, we have to put over there. Later on, just satisfy the carbon valency. This is the way we can answer. Move on to compound number 2. Compound number 2 is a 4-propyl 2-methyl heptane, right? So 4-propyl heptane stands for what? First of all, let's draw the skeleton. So parent skeleton is of 7. Hepta stands for 7 carbon atoms. Put 7 carbons in the straight chain, and they mentioned with the 4-propyl 2-methyl. So put a 3 carbon length chain on the 4th carbon, to 1 carbon length chain on the second carbon, so that 4-propyl 2-methyl completed. Later, just to satisfy the carbon valency. So you have to check 4 bonds are there around the carbon or not. For that purpose, first carbon 3 bonds. Wherever terminal carbons are there, all terminal carbons you have to give 3 bonds. So if 3 bonds already there, one more hydrogen only required. Only 2 bonds are there, 2 hydrogens you need to put. This is the way we have to assign. And this is the complete structure of the given compound, where 4 ethyl is there, 2 methyl is there, heptane is the parent chain. So whenever compound is given, we have to give the name. Whenever name is given, we have to assign the chemical structure as per the IUPAC protocol. So 2 compounds are given. Question number 1 regarding IUPAC protocol, IUPAC naming. As per the IUPAC naming, how to draw the chemical structure completed. Move on to second question. This is taken from Cambridge Assessment International Education. Here multiple questions are given. We have to go for one by one. Write an ionic half equation for the reaction at the negative electrode. For what reaction? Concentrated aqueous potassium chloride undergoing electrolysis. This is the condition. Potassium chloride was taken, electrolysis was conducted, and what half cell reaction carried at a cathode? Cathode is the negatively charged in electrolysis process. We will see that. What is electrolysis? By applying the electric current, if any compound got dissociated into cation and anion, is said to be electrolysis, right? All the cations obviously moving towards cathode, anions moving towards anode. Cations to cathode, anions to anode. Cathode is of negative, anode is of positive sign. This is the way you can clearly mention electrolysis of potassium chloride. They are asking for the possible half cell reaction in a cathodic half cell. Cathodic reaction will be potassium able to accept the electrons and convert it into liquefied potassium. This is the possible reaction. Acceptance of electrons you can clearly see over here, and that potassium positive will deposit as a potassium liquid over the cathodic region. And move on to question number 2. Name the product formed in the positive electrode called anode. Anode, what anode is doing? Anode is taking chlorides, no? Whenever chlorides are moving towards the anodic region, they will lose the electrons in this manner, and the chlorine gas will be evolved. Bubbles of chlorine will be evolved at the anodic compartment, right? So that you can clearly observe the gaseous chlorine along with the release of 2 electrons. It is said to be an oxidation process. Always release of electrons called oxidation, right? This is the possible reaction in the anodic half cell. Move on to third question. Name the potassium compound that remains in the solution after electrolysis. These are the possible reactions. Anode is accompanied by chloride converted into chlorine by releasing electrons, and a cathode accompanied by potassium accepting electrons converted into metallic potassium. They're asking for, after the electrolysis, what potassium compound is left? After the electrolysis completed, the potassium compound left is called K. That is called metallic potassium. It's a K. It is mentioned here. It's a K. Potassium will be left over. This is the way we can answer all 3 questions related with electrolysis of potassium chloride. Potassium chloride when electrolyzed, cathodic half cell, anodic half cell was given, and here potassium compound left will be potassium itself. Metallic potassium will be there. Question number 2 is detailed discussion got completed. Move on to question number 3. Question number 3 is collected from JEE Advanced 2021 question paper August with the solution. The correct statement related to oxo acids of phosphorus. Oxo acids of phosphorus are provided. We have to see, we have to check which one is correct regarding the given phosphorus compounds. Okay. Upon heating, H3PO3 undergoes disproportionation reaction to produce H3PO4 called phosphoric acid, and PH3 is called phosphine. Disproportionation possible for this phosphorus acid or not, and these 2 compounds will be generated. Is this reaction feasible or not? We have to check out. Let's see. Disproportionation stands for any compound itself converted into one oxidized product, one reduced product simultaneously. That is said to be disproportionation. Itself converted into one of the higher oxidation compound and either lower oxidation compound called reduced one, right? So both the possibilities with the same compound is called water disproportionation. H3PO3 is the compound converted into H3PO4 and PH3. In this compound, if you see, H3PO3 is with the 3 oxygens, H3PO4 with the 4 oxygens, so that it is oxidized form. If you see second compound, here 3 oxygens, but in this oxygens lost, so that we can say this is a reduced compound. One is oxidized, one is reduced, both generated in the same reaction. Hence, we can say it is the disproportionation. This is the way first one is correct. Move on to second. While H3PO3 can act as a reducing agent, H3PO4 cannot. Let's see whether it is possible or not. H3PO3 is given. Can you find H3PO3 anywhere? Here is the H3PO3. Here, H3PO3 is having H, P, double bond O, OH, OH. This is the way you can see. This is called phosphorus acid. Okay, it is called a dibasic. Dibasic means it readily releases H plus. How many? Here one H plus is free. Here one H plus is free. But whatever pH bond is there can't be polarized. We are not supposed to remove this hydrogen being it is highly firmly bonded to phosphorus. so that only 2 hydrogens will be liberated, though we have 3, but the freely available H plus are only 2, so that we can say it is dibasic. The possibility to release the H plus is called its a basicity, right? How many are releasing? 2. Hence we can say dibasic. Okay. And this phosphorus is having here -2, here -1, here -1, and +1. Total minus charges are 4. Total plus charges is 1. So that our total negative charge will become -3. So phosphorus is accorded with +3 charge. Here in phosphorus acid, it is in +3 oxidation state around the central phosphorus, right? So +3, the possibility for +3 into +5 is there. So +3 can be converted into +5. Higher oxidation state is also possible for phosphorus, no? So that it will accept the electrons, or else, sorry, it will release the electrons, and there is a possibility to work like a reducing agent. So here +3 is possible and it further oxidized. So +3 can be converted into +5. That means what? Itself it is oxidizing. If any compound itself oxidizing, it able to reduce some other compound. That's why itself it will be oxidized to +5 and it acts as a reducing agent. Okay, so this is regarding H3PO3. Strongly, it is the reducing agent. It is clearly explained. Move on to H3PO4. If you see H3PO4, let's count oxidation state around the central phosphorus. Here, -2, -1, -1, -1. Total negative charge is -5. Around the central phosphorus, +5 will be there, no? So that is the maximum possibility of phosphorus oxidation state, so that it will not release electrons further, so that it will not oxidize, because it is the highest oxidation state around the central phosphorus. So it having tendency to accept the electrons now. So it will reduce. Whenever it is reducing, it acts as an oxidizing agent, so that phosphoric acid is acting as a oxidizing agent. Phosphorus acid acting as a reducing agent. Both are not oxidizing agent, or both are not reducing agents. Okay, what they are saying, H3PO3 acts as a reducing agent. It perfectly correct. H3PO4 cannot. It is also correct, because in H3PO4 we have highest oxidation state around the central phosphorus, so that it is not able to oxidizing. So whenever it is not oxidizing itself, so that it will not act like a reducing agent. So it is correctly explained. So option B is also correct answer. H3PO3 is a monobasic acid, they are saying. So just now we saw H3PO3. Is it a monobasic or dibasic? Monobasic stands for it able to release 1 H plus. Dibasic stands for it able to release 2 H plus. Tribasic stands for 3 H plus released. But it is the dibasic acid. Why we are saying dibasic? 2 OH ions are there. 2 OH bonds are there, which are highly polarizable. Polar bonds will be there. H plus readily released from OH, but not from pH. So that H plus is given from this OH and this OH, hence we can say dibasic. H3PO3 is the dibasic rather than monobasic. This is the wrong answer what they are saying. So it is not mentioned with the tick mark, right? So move on to option D. Hydrogen atom of pH bond in H3PO3 is not ionizable in water. Okay. So this is perfectly correct. What they are saying, pH bond. So where can you see the pH bond? Here is the pH bond. Whenever this H3PO3 is added to water, this pH bond can't be ionized. This will not be converted into P plus and H minus, or else H plus and P minus, because this bond is not a polar bond, rather it is a non-polar. But whenever OH bond is there, this H plus readily released. This H plus also released, but pH bond is strong, non-polar in nature, which can't be ionized under aqueous conditions. What they are saying is correct only, non-ionizable in water, so that it is also mentioned with the correct asterisk mark. Okay, so this is the way A is correct, B is correct, D is correct, rather C is wrong answer. So for question number 3, Multiple options are correct. A, B, and D. Move on to question number 4. Question number 4 is given from the paragraph. If we read the paragraph thoroughly, then only we can answer the following subsequent questions. The reaction of K3FeCN6. So potassium percyanide will be taken. It is added with freshly prepared ferrous sulfate. Ferrous sulfate always freshly prepared. Why we can't store ferrous sulfate in the laboratory means ferrous sulfate is in +2 oxidation state on the central iron, and it is highly unstable in nature. It will participate in air oxidation, so that ferrous to ferric is immediately possible. Within short span of time, ferrous will be turned into ferric. That's why it should be prepared within the at the time only. Freshly prepared is mentioned that purpose. Okay, because ferrous is highly unstable. Freshly prepared ferrous sulfate solution produces dark blue precipitate called Turnbull's blue. Whenever these two compounds are mixed, most of the complexes are colored, intensely colored in nature. That's why they are working like a dyes, coloring matter, pigments, right? So here, this K3FeCN6 upon treating with the ferrous sulfate, here one colored compound will be generated called Turnbull's blue. So this is a colored compound. What they are saying, reaction of K4FeCN6. Okay, so K4FeCN6, K3FeCN6, what difference you can find here? Iron is in +3 oxidation state around the central iron. Here iron is in +2 oxidation state around the central iron, right? Whenever this K4FeCN6 is treated with FeSO4, the solution in the complete absence of air is not there. So in the absence of air, we are treating, white precipitate will be formed. So what white precipitate formed, we need to identify which turns blue in color. So initially it formed as a white color precipitate. After some time, it will be converted into a blue color. Mixing with ferrous sulfate solution, with the sodium nitrate, followed by slow addition of concentrated sulfuric acid through the sides of the test tube, produces a brown color ring. This is the complete description for the brown ring test. Let's see how can we explain that one. For precipitate X's, what is the compound X in this? Compound X for what? K4FeCN6 means Fe+2 will be there treated with FeSO4. At that condition, compound formed will be ferrocyanide will be formed. This will be the correct answer. And whenever this is performed, this entirely described as a brown ring test. The brown ring test is simply given with the iron pentaquo nitrosyl cation. So this is the right representation. Pentaquo nitroso compound will be there. Pentaquo nitroso compound will be there. So here aqua taken 5 times are required. That is given only in the option number D. Let's see detailed description about this one. Whenever ferrous sulfate or adding with K3FeCN6, this is in ferrous, this is in ferric. That means Fe+3 form. Okay, Fe+3 will be there. Fe+3 oxidation state around the central iron will be there. Upon treating, this will be converted into Fe3FeCN6 taken twice. This, which color it is? Turnbull's blue color in nature. So this is a compound generated upon treating with Fe+3 with ferrous sulfate. And another one, Fe+2 was taken. Ferrous sulfate treated with K4FeCN6. There is a compound Fe2FeCN6 will be formed, which is white in color in the absence of air. White color compound will be formed. And they're asking for brown ring test. Another question, they're asking for brown ring test. Brown ring test is performed with the ferrous sulfate, sulfuric acid, nitric acid. Any nitrogen containing compound is added with freshly prepared ferrous sulfate, and the test tube was taken in the slanting position, and drop by drop sulfuric acid is added from the walls of the test tube, just like this. Drops of sulfuric acid is added through the dropper, and so if you are taking directly adding sulfuric acid, it will spill onto your face. That's why we need to take care regarding the addition of sulfuric acid. Being it is a very strong acid, a drop by drop addition is required, very essential over here. whenever it is added, formation of Fe to SO4 taken thrice will be formed, and NO. This is the important compound which generated here called nitric oxide. NO is called what? Nitric oxide will be generated. That nitric acid, nitric oxide will be treated with the reagent here. This is called the reagent. FeH2O taken 6SO4. Hexaquo iron sulfate. Hexaquo iron, what is the oxidation state here? 2. Iron 2 sulfate, hexaquo iron 2 sulfate here. This will be treated with nitric oxide. What happens here? The substitution is possible. One of the water will be replaced with NO, so that NO will be added inside and water will be removed. Simply we can say ligand substitution. This is the kind of ligand substitution, and whatever product formed is brown ring in color, which is generated at the junction of two layers. So you can notice upper layer is blue in color, bottom layer is pink in color. In between the junction, you can find the brown ring, which is called what? Penta-aquo nitrosyl iron 3 sulfate. This is the compound generated. So this is responsible for the formation of brown ring in between the layers of two liquids. So by this, this answer is also explained. So nitrosyl, NO is required, pentaquo is required, iron is required containing dipositive charge. This is the right representation for brown ring test. So for question number 4, two different questions are two different questions and two different answers we mentioned, and detailed explanation is also given. Move on to question number 5. Question number 5 again collected from the Telangana Degree College Lecturer Gurukulam Entrance Examination. So in that match the following question was given. Here it is the part of again chemical equilibrium question. Acetic acid. Acetic acid is said to be weak acid, and mentioned in a square bracket indicates what? It's a concentration. It is given exactly is equal to sodium acetate. Sodium acetate is the salt of acetic acid only, no? So sodium acetate again mentioned in the square bracket, whose concentration is also 1 into 10 to the power minus 2 moles. So here, this is about what? Weak acid concentration is equal to its salt concentration is equal to 1 into 10 to the power minus 2, right? So next, degradation of dissociation, 0.1 at HX concentration is equal to 0.1 molar. Ammonium hydroxide is a weak base in water. Ka stands for dissociation constant of an HX is 2 into 10 to the power minus 5 in the water. These are the options given. What answers will be exactly mapped with this one we have to go for. In order to explain, we have to solve the problem one by one. Let's see. In order to explain this one, we have to go for the equation called calculation of pH for the buffer solution given by Henderson equation. Henderson-Hasselbalch equation, which is important for the calculation of pH for the buffer solution. Buffer is the solution which maintains the constant pH, whose formula is given by pH is equal to pKa plus log of salt concentration by diluted acid concentration, right? pH is equal to pKa plus log of salt concentration by acid concentration, right? Here we have acetic acid, sodium acetate, and whose concentration is given as 1 into 10 to the power negative 2, right? So let's put over here pKa plus log of 1 into 10 to the power negative 2 by 1 into 10 to the power negative 2. Both the terms are exactly equal, both get compatiated. We can cancel out. Log 1 value is 0, no? So that log 1 will become 0. So if log 1 is 0, pH is equal to pKa. pH is equal to pKa is the correct answer. pH is equal to pKa is given in the option number 2. The pH is equal to pKa option number 2 is given only in the this first option, so that just you can put right mark over here if you know Henderson equation. Otherwise, we can go for other terms also. Let me go with the ammonium hydroxide is a weak base in water. Ammonium hydroxide is a weak base in water. Weak base means what? Weak base means what? The pH value will be higher. If pH value is higher, what happens? first of all, let's go with the step-by-step explanation. PKB values, dissociation constant values will be there, no? So it's a logarithm of values are called PKB values. For base, B for base. Okay, so PKB is a reciprocal of KB. If KB value are higher, PKB values are lower. PKB values are higher, KB value will be lower. This is the way reciprocal relation you can find between PKB and KB. So negative log of KB is called PKB. Negative log of KB is called a PKB. Okay. KB value is high for weak base. KB value will be higher for the weak base. If KB value will be higher, what will be the PKB value? PKB value will be lower. It is the less value. If PKB value is less, then obviously PKA value will be higher. So that PKB will be smaller than PKA value. That is given in the PKB is less than PKA value given in the option number 3. For C, 3 is the correct answer. C3 is the correct answer. Move on to another one. Here, what they are asking for, this one. Ka of Hx is 2 into 10 to the power minus 5 in water. Ka value is given as 2 into 10 to the power minus 5. Okay. So if that is the case, let's put in the equation pKa value. So first of all, we have to go for what is Ka. Ka is called dissociation constant. So dissociation constant of what? A for acid, K for dissociation constant. So Ka is the acid dissociation constant. Okay. So here Ka value is given by concentration of anion into concentration of cation by concentration of salt. Okay. This is the way we can calculate. So now we have to go for the equation pKa. pKa is equal to negative logarithm of Ka. Negative log of Ka. Ka value is given in the equation, that is 2 into 10 to the power minus 5. So negative log of 2 into 10 to the power minus 5. So if you calculate this entire one, it will be 4.6. Okay. Value obtained in minus 4.6. Already minus is there. Minus minus compensated so that it is 4.6. So pKa value is 4.6. pKa plus pKb is equal to 14. But here pKa is there. We need to calculate pKb. pKb is equal to 14 minus pKa. 14 minus pKa value is 4.6. 14 minus 4.6, it will be 9.4. So pKb is 9.4. That is given in the option number 1. D for option number 1. And the leftover will be dissociation is equal to 0.1, Hx is equal to 0.1, where you can put pH is equal to 2. Right? This is the way we can solve the question. For question number 5, option number 1 is the correct answer. This is the question given from chemical equilibrium, which is purely related with the pH, pKa, pKb, Henderson equation, buffer solution, everything. Right? So hope this is very clear. Move on to question number 6. Question number 6. In each of the following statements, there is a pair of sentence. Identify the correct pair. Which is the correct one, which is the wrong one, we need to identify. The reaction Mx plus H2O gives rise to MOH plus HX is called hydrolysis of MX salt. Hence, NaCl water exists as a mixture of NaOH and HCl. If the compound taken is NaCl, MX they mentioned, M for metal, X for halide, metal halide. So that metal halide is sodium chloride. Now, sodium chloride added with water. Whenever sodium chloride added with water, the products formed not like NaOH and HCl. Rather, NaOH, Cl2 and H2 will be formed. We will see. NaCl when added to water, we will get sodium hydroxide, chlorine and hydrogen gas. This is the possible reaction. So that let me put a wrong mark over here. It is not the correct one. We have to get NaOH, Cl2 and H2O. Then only it will be correct. Move on to second one, B option. A homogeneous mixture of ammonium hydroxide and ammonium nitrate. This is called what? Buffer solution. Acts as a buffer. The pH of buffer is given by Henderson equation. This is perfectly correct. Let's see what is what. B. So here buffer solution stands for any solution which maintains the constant pH is called a buffer. Buffers are two types, acidic buffers, alkaline buffers. Are acidic buffers, basic buffers. Basic buffer is nothing but any weak base and it's a salt with strong acid got mixed, that is called a basic buffer solution. Simply, ammonium hydroxide is the weak base and it's a salt with ammonium nitrate. That mixture is called alkaline buffer. So that is the example for basic buffer whose pH will be calculated by the formula called Henderson equation. What is Henderson equation? pH is equal to pKa plus log of base concentration by acid concentration. Okay, so this is the way we can go for the Henderson equation. So that is perfectly correct. What they are saying exactly correct. B's. Move on to C. When few drops of ammonium acetate added to the aqueous solution of acetic acid, the pH increases. This is due to common ion effect. Common ion effect means here sodium acetate having acetate ions. Acetic acid is also having acetate ions. So the ions whichever common in both the compounds are called common ions. When common ions are present, that will suppress the ionization of the compound called the common ion effect. We will discuss in detail about that one. Okay. Dissociation of acetic acid is suppressed. Suppressed means decreased by the addition of the compound called sodium acetate. So in sodium acetate, you can find CH3COO. Acetic acid also you can find CH3COO. This part is common, which is called common ion. Here the common ion is CH3COO minus. The CH3COO minus, what it will do? It will decrease the amount of ionization of compound acetic acid. That is called a common ion effect. So whenever this CH3COO minus concentration or dissociation decreases, H plus ions also released in the lesser extent. So whenever H plus ion count decreases, H plus ion decreases, pH will be increased because less the H plus ions, more will be the pH. That's why pH value increases. So what they are saying perfectly correct. When few drops of ammonium acetate added to the solution of acetic acid, pH increases. This is due to what? Common ion effect. This is also perfectly correct. We can say a tribasic acid that can release 3 protons sequentially. The overall pKa value is given by pKa1, pKa2, pKa3. Tribasic acid means what? The compound which is able to release 3 H plus ions. pKa stands for what? Negative log of Ka is called pKa. Ka is called what? Acid dissociation constant, no? So whose negative logarithm value is called pKa. So pKa for tribasic acid, H3PO4 is the best example for tribasic acid, where 3 H plus are freely released, so that we can say it is the tribasic. Here you can see 1 H plus, 2 H plus, 3 H plus released. But the thing is, total pKa is equal to, that is not the product of pKa, pKb, pKc. Rather, it will be the sum of pKa1, pKa2, pKa3. So we can take the total of pKa is equal to pKa1 plus pKa2 plus pKa3. So that half of the part is correct. Half of the part is correct. Tribasic acid releases 3 protons, correct, but pKa is equal to product of pKa1, pKa2, pKa3 is the wrong one. So we can't put D as the correct answer. Only the correct answers are B and C. B and C are properly related. This will be the right option. Option number 2 is the correct answer for 6th question. Again, it is the part of what? Chemical equilibrium only. That's why we are saying in the intermediate level, chemical equilibrium finds a higher level weightage over there. And most logical part, if we think in multiple dimensions, then only we can answer this kind of questions. Hopefully this session, whatever we discussed now, is completely clear, and it will be helpful for your preparation, and it will increase your enthusiasm towards the chemistry. And I'm sincerely requesting you to like the channel, comment which part is really interesting for you, and share with aspirants who are seriously preparing for any kind of examination, and subscribe the channel to receive more such updates. Thank you very much for your patient listening. Thank you one and all.